In this video, we will look at how to determine which species in a solution will react together. Further, we're going to determine the extent of the reaction by looking at the equilibrium. As a review, we have to remember that according to the collision reaction theory, there are many collisions that happens, and therefore there are many possible reactions that could occur. However, for Bronsted-Lowry definitions, the majority acid-base reaction should be the one that is the strongest acid reacting with the strongest base. And there is a 5-step method for predicting which of these acid-base reactions will occur. The first step is to identify all the entities, ions, atoms, or molecules that are present in an aqueous solution. If you have an ionic compound such as calcium hydrogen carbonate, it will dissociate into cations and anions such as calcium ions and bicarbonate ions. Whereas if you have ionic oxide such as sodium oxide or calcium oxide, it would dissociate into the cations such as sodium and calcium, as well as the hydroxide ions. Next, any strong acids that are present will ionize into hydronium and their conjugate base, and weak acids will remain as a molecule, so something such as hydrogen fluoride will stay as hydrogen fluoride. Similarly, weak bases such as ammonia or hydrogen carbonate will remain as a molecule of ammonia or hydrogen carbonate. The next step is to identify all the acids and bases in the solution according to Bronsted-Lowry definitions. A couple important points to remember is that hydronium is the strongest acid possible, and hydroxide is the strongest base possible. If there are any strong acids in solutions, such as these 6 strong acids, or any bases containing OH, you immediately have hydronium as well as hydroxide in your solution. Step 3 is to find or identify the strongest acid and the strongest base using the strength of aqueous acid and bases chart in your chemistry theory data booklet, and that can be found on pages 8 and 9. Step 4 is to provide an equation that reacts the strongest acid with the strongest base. We will then transfer the proton, the hydrogen, from the strongest acid to the strongest base. On the product side, we're going to predict the conjugate base of our acid as well as a conjugate acid to our base. And the final step is to predict the position of the equilibrium. Will the forward reactions be favored or the reverse reaction be favored? If in your strength of weak acid and weak bases table, the strong acid is above the strong base, we are going to say that this reaction happens more than 50%. We are going to say that the forward reaction is favored. However, if the opposite is true, if the strong base is above the strong acid, we're going to say the reverse reaction is favored, or that it happens less than 50%. So let's now go through the steps with a specific example. What is the predominant reaction if spilled drain cleaner, sodium hydroxide, is neutralized with vinegar? And is the reactant or the products favored? Again, or is the forward reaction favored or the reverse reaction? First thing we're going to do, we're just going to list all the entities present. Because sodium hydroxide is a strong base, it will immediately dissociate into sodium ion and hydroxide ions. Vinegar, acetic acid, being a weak acid, will remain a molecule of weak acid. And don't forget water, because this is an aqueous solution, so water is present. Next, we're going to identify the acids and the base. According to our acid and base table, acetic acid is an acid, as with water. On the other hand, hydroxide is a base, as with water. Looking again at our acid and base table, we see that strong base is our hydroxide because it is the lowest on the right-hand side. On the other hand, acetic acid is going to be our strong acid because it is the highest on the left-hand side, on the side of the acids. Next, we're going to write a balance equation to show a transfer of proton from the acid to the base. So we've identified the acetic acid will lose its hydrogen to NaOH, so that you're going to form water. Water is a conjugate acid of hydroxide, and acetic acetate, is the conjugate base of acetic acid. And the last step in our example is to predict whether the products will be favored, that is the forward reaction, or the reactants will be favored, that is the reverse reaction. Here we see that our strong acid is above our strong base. Therefore, according to our rule, this reaction will happen more than 50% of the time. In other words, the forward reaction is favored. Or, and put it into another terms, the products of the reaction will be favored.